Well, it's easy to go down a rabbit hole, and I've sure gone down enough of them on this project. The mod DMod board here is fine. No problem with it. In fact, this is the one out of the spare unit, and I still had what appeared to be a short. But what I found out, the problem is not, and here is the connector, the bottom of the connector for this board on the other side. As you look here on the bottom here, this would be 10 volts almost. I gotta adjust that. Here's the minus 12, and here is the 5. The problem isn't on this board. The problem is somewhere down this cable that's pulling the 10 volt supply down. So what I need to do, I'm going to remove some of these ties here so I can separate the cable. I need to measure here where the 10 volt is being loaded down here and then trace it up into the circuitry here. It might be a mess. I may have to pull this front off. Not looking forward to that. But anyway, you can see how you can get misled thinking, well, this is plugged in and I'm pulling my supply down, so the problem must be on the other side. No, the problem's down the other end of here. So that's where I need to look into next. Here's the suspect connector where we're getting that fault. I have this probe on the pin where the 10 volts is fed into this cable here, and I'm measuring to ground, and I'm measuring 0.3 ohms. So, or 0.2 ohms, according to Ohm's law, that would be what, 45 amps or so. So no wonder that's pulling this 10 volt supply down. So that confirms that we've got a shorted component or something on the other end of this cable. So I can trace that out and maybe hopefully track down what's pulling that 10 volt supply down. Now on this connector there's an orange wire. I don't know if you can see it here on this bottom connector on the right side, looking from this side. That runs up this harness, and this is why you need to do a really good inspection before you power these things up. Here's the Yig oscillator here. What I found, that orange wire, and I don't know if you can see it, the white with orange, they're cut. And I'm not sure where they terminate. But anyway, this orange wire was touching the metal frame of the Yig oscillator here and shorting out the 10 volt supply. So that's where our short is. Now I got to figure out where those two wires go. Now somebody must have removed those during some type of a troubleshooting procedure, but they left them floating, so they ended up shorting the ground. So I'm going to isolate those so they don't touch. I'm going to plug that connector back in, turn on the supply, and make sure that my 10 volts is not decaying. I'm going to try that next. Then I got to figure out where those two wires go, the orange and the white with the orange stripe. Or is it a brown stripe? I can't tell. I'll check the manual. I separated that orange wire that was touching the frame of the Yig oscillator, and I plugged this connector back in, and lo and behold, there's our 10 volts. So, why did they disconnect the orange wire? I'll have to find out where that goes. And if it goes to the Yig oscillator, if that thing's bad, this thing is basically a boat anchor. Unless I can pull the one out of the other unit that's good, I don't know. That's the other possibility. That's going to be major surgery though if I have to do that, but I think it'd be worth it to get this thing running. But anyway, I found out what was shorting that 10 volt supply out, and that's good. So I'm moving forward after getting out of the rabbit hole that is. You can see how easy it is to get sidetracked here, thinking that the problem was on the mod-demod board when the problem was actually up the line here into the near the gig oscillator. So time to move on to the next step. I don't know how in the world I missed this. A little embarrassing, but I have to admit it. The orange and the white and orange stripe went to FM cal offset. I'm missing a pot here. How did I miss that? So anyway, on my other unit, my donor unit, I actually have that pot. So somebody removed that pot. I don't know why, if it was bad or whatever they did. But I guess we better find out a replacement for that. I pulled a 10K pot. This is a multi-turn 10K pot out of the donor unit, and I'm going to test the resistance here from both sides. And it tests alright. 10K, yeah. Okay. So I'm going to transplant this unit into this unit, and we'll see what happens from there. Maybe magic. I doubt it. So far, magic has been very elusive in this project. I transplanted that 10K multi-turn pot, which is right down there, the black. I had to remove the meter. I thought I'd have to remove the front panel in this darn thing, but luckily I was able to squeeze in there. Once I took the meter out, I had access. So I replaced the pot, FM calibration offset pot. So that's replaced. Although I had a feeling that wasn't our main problem. I could have used my lovely assistant Patty, but she's up sleeping. Actually, I woke up at midnight. I woke up out of a sound sleep and I came downstairs, and it kind of took me right to where I found this. For some reason I must have dreamt about it. But anyway, that replacement's in there, so let's move forward. Well, I'm making a little bit of progress here. Got the unit on generate. The unlock light now went off. I've got it set for 443.150 megahertz. Same thing in the handy talkie. And I'll turn up the modulation here. You can see the meter's deviation. It's responding. And I'm picking up just there, high level. That's full quieting. There's 5 kilohertz deviation. Now wait a second here. There we go. There's 5 kilohertz deviation. And I can turn the attenuators work, and I can turn it. So the generator's working, but still no receive. So we'll have to figure out what's going on. That demodulator board. You know what I think I'll do? I'll replace that with the other unit. I've got another mod-demod board. I think I'll put that in and see what happens. Just try to substitute it. Do that next. Well, I got the receiver working, but it isn't very sensitive. I ran in 500 microvolts. Well, I'm going to try the handy talkie first. You can see. Whoa, test 1, 2. Oh, there we go. Yeah, we got a hello testing. 1, 2, 3, 4. I'm about 3 feet away. Testing 1, 2, 3. Test 1, 2, 3. Something was intermittent. Might have a. There's a couple relays in there. I should probably clean. Hello testing. 1, 2, 3. Test 1. 1, 2, 3. Test 1, 2, 3. Test. 443.150. Let's try generate again.
Frequency mode.
Okay. Okay, that's working. Okay, so it seems to be generating the receiver. Now there is an RF amp on this unit here. Why the sensitivity is so low, I guess I'll have to investigate that next. But it's coming back to life. I need to clean a few of these switches. I know this, I had a little intermittent on this switch here. If you watch the unlock, so evidently you can feed in a 10 megahertz signal in the back, but this switch is kind of intermittent. You can see as I move it, but that basically just disconnects the internal TXCO and connects it to an output on the back, which is nice because I can hook my GPS discipline oscillator to the thing if I even use this. I don't know if I'll use this that much, but anyway, we're making progress a little at a time. Got to get this, find out why the receive sensitivity is so low. This unit doesn't have a signal strength meter. It has a signal level here, a little LED, and it seems to get brighter as the signal goes up. I'm running in 1 microvolt. Whoops, there. Running in 1 microvolt. I'm going to increase the input in 1 microvolt increments. So there's 2 microvolts, 3, 4, 5, 6, 7. There's 7 microvolts. Signal level lights on. I'm running in 100 megahertz at 6 microvolts amplitude. Got it set for 100 megahertz. Got it on frequency air on 1.5 kilohertz, which would be the lower scale. So I'm going to change the input here in 100 hertz increments. So there's 100 hertz, 200, 300, 400. It's off a little bit. There's 500 hertz difference, and we're just a hair below 5, pretty close. So the frequency error meter seems to be working properly. There's 10 microvolts input. You can adjust the sensitivity. Yeah, this isn't as versatile as some of my newer, like my my HP service monitor. But this is kind of a neat little unit for its time. I don't know if there's been any tweaking done in any of the circuits in here. Maybe I can go through the alignment and stretch a little more gain out of it. It seems like it could be a little more sensitive. I'm going to run it back down. There's 7 microvolts, 6, 5, 4. The signal level light's still on. There's 3, 2, 1. Okay, the signal level is off, and that's at 1 microvolt. So, well, at 2 microvolts, we're getting a little indication there. So maybe we're not too far off. Bring it back up to. There's 10 microvolts. And of course I can vary the. There's 400 cycle modulation, kilohertz. Well, other than it seems to be working okay. Let's go back to generating a signal and check this out here. We'll do that next. I have an old Radio Shack HTX 404 on 443.15. Got 443.15 dialed into the unit here, and I'm going to increase the output. And as I increase, you can watch the signal intensity come up on the HT, so that's working. This has a higher level on it too. I can yeah, the attenuator seems to be working here. Well, seems to be, I think I got it fixed. I might have to do some fine refinements on it. I got to clean it up a little bit. I did, I replaced the meter. This one is kind of foggy from the donor unit, and this one has a nice screen on it. So I replaced the meter there. This FM calibration offset pot, it's a 10-turn pot. That was replaced. So I think I'm going to close this one out. I'm not going to go through the alignment because that would take too long. I just wanted to get this thing working. So that will be the end of this series, part 2 of the Cushman CE 31B. So I'm not sure how much I'm going to use this rig, but it was kind of fun. Went down a few rabbit holes, but I got out of them. Woke up at midnight and something hit me, and I thought, wait a minute, I got to check something out. So I came down. Right now it's what is it, about 4 a.m. I think. So my lovely assistant's up sleeping. So I could have used her when I soldered in that pot here. Anyway, I think that'll do it for this one. The other part 1 was kind of long, so hopefully this one was a little better. Anyway, thanks for watching. I hope you enjoyed it, and I'll see you in the next one. Bye for now.